A number of students have been asking me to show them how to do the extra credit problem that we've been working on our Chapter 6 review sheets, and I'd like to make this video to help you learn how to do that. Let's just say, looking at number 23, you have a sheet of 40 centimeters by 32 centimeters. 40 centimeters would obviously be the longer dimension. Here's our 32. But we're going to cut square corners out to be able to make a box. So we're going to be cutting these X dimensions. We don't know the size of the cut we're going to be making. In fact, that's answer choice A. We have to find that. But sometimes students are even wondering, how would that even look like a box? Well, you'd be able to fold along these creases here and then be able to, of course, fold that up and eventually make a box that would look something like so. So as you're losing those square corners, please understand you have 40, but what I'd like to point out is you're losing a dimension of X centimeters and X centimeters over here. So you're going to lose 2x. So this is going to be 40 minus 2x on the inside here. Vertically, you can say, well, you've got 32 centimeters going up and down. But again, what's going to happen is you're losing two vertical components that I've highlighted here. So the 32, you're going to lose this x and x. You're going to have 32 minus 2x on this inner portion. So really what you're going to see is this is going to be the floor here. These little rectangles on the outside are going to be the flaps that get folded up. So we're going to have 40 minus 2x on this rectangle width on the inside. The other dimension here would be 32 minus 2x. That would be coming this way. And then, of course, as you're folding these flaps upwards, this piece will actually become the height. So what you have here is the volume of a box is, of course, length times width times height. And you'll have 40 minus 2x times 32 minus 2x times x. And that's how you can find your volume. What you would like to do is to be able to enter this into the calculator to be able to graph it. So we'll take out our 84, and I'm actually going to put the x first. Type in a 40 minus 2x. Then we'll have 32 minus 2x. And if we were to just graph this on a standard window, you might get really confused. It looks like nothing has happened. The whole point is, though, that the volume, which is like our y1, is going to have some very big values. When you press trace and you go to the right, you can see, like when x is 1.27, our y value, which is our volume, is actually 1,407. And as you continue moving, you can see that our volume is growing. It's now over 3,000. Looks like it's getting around 3,300 something, and that looks like it's going to come down. So tell you what, if we went to our window button, windows on that top row, I'm going to change my Y max. Maybe give us a little room here and say that's 3,500. The Y scale, let's have tick marks for every 1,000. And this is going to allow us to see the shape of this curve. When we hit graph, right now you can see it's looking something like that. And of course this would be volume on the y-axis. X is the dimension of the square that was cut off, a side of a square. What we can do real quickly is hit second calculate, and we'd like to find maximum. We'd like to find the highest point. Left bound, well, we could just type in -10. We still have a 10 by 10 window, so type in +10. Guess, well, right now you might wonder where we are with that highest point up there. To me, it looks like we might be around 5, we might be around 4, something like that. Even if you hit the right arrow or left arrow, I did that inadvertently. It jumped around a little bit. Let me just hit 5 just to have a little bit of a guess. That's not a bad guess at all. I thought it was in the middle of the screen there in the first quadrant. So 5.89 roughly, 5.89 for x. And my y value is 3,360.88. So 5.89 for x. The y value, bring that back up, 3,360.88. Well, this right here is the size of the cut. That's what x was. It's 5.89 centimeters. What is that maximum volume? Well, that's your y value that you just graphed. So it's 3,360.88. We'll have to say square centimeters. So again, what you have to do is realize that as you're able to cut out those corners and you're going to fold your flaps up, you're going to have new dimensions of your box. I think one of the trickiest parts is folding these little flaps up here is how your height is going to be x. Sometimes it's easier to actually see a piece of paper with the square corners cut out and folding them up. Well, hope this helps.